What's going on, guys? My name is Amos and I'm back again with another video. So in today's video, we want to talk about sequences. So whenever we have some infinite sequence, let's say S sub n in this particular case, so we have some infinite sequence S sub n, and then if we decide to sort of like drop some terms of S sub n and then maybe get and leave out some terms of this sequence S sub n, we see that we generate another infinite sequence. In this case, we call that infinite sequence B sub n. Then this sequence B sub n that is going to be extracted from the existing A sub n sequence is basically going to be a subsequence of this sequence A sub n. So another important thing to note here is that the sequence A sub n is basically going to be an infinite sequence, and then the sequence that is going to be extracted from A sub n is also another infinite sequence. So we can take some example here. We can look at some example here. So let's say we have the sequence, A sub n that is basically equal to 1 divided by n. So let's say we have A sub n is equal to 1 divided by n. Then maybe let's write out a few terms of this sequence. So the first term is 1 divided by 1. And then here, let's specify that n is coming from n star. And then we have 1 divided by 2. And then we have 1 divided by 3. And then we have 1 divided by 4. And then 1 divided by 5. And then we can go on, and maybe 1 divided by k, like so. And then the terms, keep on going, because this is an infinite sequence. Then if we extract this sequence here, a to n. Now here, there's one thing that we are supposed to, observe, one thing that we're supposed to respect about this function that we have here. So here, we have a function of n, f of n is equal to 2n. Now, this function, according to this definition that we have here, this function has to be a mapping from the set of natural numbers into the set of natural numbers. So here, let me write it here. We see that f has to be a mapping from the set of natural numbers into the set of natural numbers. And then this function or this mapping has to be strictly increasing. So meaning we must have n's such that n1 is strictly less than n2, which is strictly less than n3, and then which is strictly less than n4. And now because our function is strictly increasing, what is going to happen is that if I compose this and sort of like take my function here, I'm going to have this basic situation. So all in all, we must have n's such that we have, n1 is less than n2, less than n3, and then the numbers keep on going like so. So if we extract this sequence a to n, now 2n here is going to this sequence is going to contain the even term. Is going to have even values of n. We'll be basically using the even terms, right? So here we're going to have 1 divided by 2, which is going to be our first term, and then we'll have 1 divided by 4, and then we'll also have 1 divided by 6, then we'll also have 1 divided by 8, and then we have 1 divided by 2k, and then the terms are going to continue. So if you look at this value, this is my n1, here, this 2 that we have here is my n1. So if we look at this number here, this is my n2, we see that n1 is going to be less than n2. Now same thing here, this is going to be my n3. Let me just circle it like so, and then we observe the same pattern here. And then we can also extract another sequence. We can also extract another useful sequence, which is the sequence a to n plus 1, like so. Now, which is going to contain the odd values of n. So here we're going to have 1 divided by n, 1 divided by 3, 1 divided by 5, and then we have 1 divided by 2k plus 1, 1 divided by 2k plus 1, 2k plus 1, and then the numbers keep on going. So we see that this is also an infinite sequence, and then this is also an infinite sequence. So this is our b sub n, and then this is maybe our c sub n, if you want to basically follow what is happening here. And then a sequence like this one is not a subsequences. So examples of sequences that are not subsequences of 1 divided by n. So let's look at this sequence here. Let's look at this sequence. Maybe let's call it d sub n. And then we have a sequence like this one, 1 divided by 2, and then 1 divided by 1, and then 1 divided by 4, and then 1 divided by 3, and then if we keep on going like so, then this sequence is not going to be, this one is not a subsequence. So this one is not a subsequence. Not a subsequence. Not a subsequence of the sequence 1 divided by n. So this is very clear to understand, that this is not going to be a subsequence. Right. So we can have many examples of sequences that are not subsequences, but then we basically want to leave it here. And then one very interesting thing about sequences and the subsequences is the fact that if the sequence a sub n converges to some limit a, then all the subsequences of the sequence a sub n are going to converge to the same limit, which is a. Right, so very important piece of information. And in fact, we can use subsequences to check if a particular sequence is going to be convergent or not. So if we can find two subsequences of some sequence a sub n, and if those two subsequences converge to different limits, then the sequence is not going to be a convergent sequence. Now let's give ourselves some example. Now let's give ourselves some example of this, of a particular situation. Let's say we have some sequence b sub n, which is equal to -1 to the power n. And then now two subsequences of this sequence. So we have the sequence b to n, and which is going to have 1. So 1, 1, 1, 1. So if you plug in any even number here for n, you basically get 1s, and then this sequence continues. And then this goes to 1. This goes to 1 as n goes to infinity. And then we can extract another subsequence, which is b to n plus 1, which is going to have -1, -1, and then -1, and then -1, and then all the other terms. So this is going to go to -1 as n goes to positive infinity. So we see that this sequence is not going to be convergent. This sequence, we know that this sequence is not convergent, but then here we want to use the subsequences. So we found two subsequences of the sequence b sub n that converge to different limits, and so this one is not convergent, right? Because if a sequence is convergent, then all these subsequences have to converge to the same limit as the given sequence, in this case, which is a sub n. So here it does not work. And then another interesting theorem on subsequences is the Bolzano-Weierstrass theorem, which tells us that from every bounded sequence, we can basically extract a convergent subsequence. So if we have a bounded sequence a sub n, we can extract at least one convergent sequence, which is going to be a sub nk. Thank you guys for watching, and I'll see you in the next video.